Here I'll show you how to determine the value of one trig function from the value of another trig function using algebra only, as opposed to drawing pictures of right triangles. So here's an example. If I want to write sine of theta in terms of cosine of theta, what that means is, what our goal is to have sine of theta equals some expression with the only trig function involved being cosine. So I can't have a tangent or a secant over here. I could only have cosine. So I'm trying to solve for sine. Now I need to determine a relationship between sine and cosine, and we have a Pythagorean identity, sine squared plus cosine squared equals 1. So all I have to do is make it look like our goal and solve for sine. No problem to subtract. Now we'll take the square root, and that means to take the positive or the negative square root. And I want to make a point that when you take the square root of this guy here, you do not get 1 minus cosine theta. You can't take the square root of 1 and the square root of cosine squared separately because of they're combined with this minus. Okay, so you can't separate them like that. So this is as simple as it gets here with the square root left in. Furthermore, what this is useful for is if I know a value for cosine of theta, I could actually plug it in, square it, subtract it from 1 and take the square root, and that would give me the value of my sine of theta. Alright? The other interesting aspect of this problem is the plus or minus. The plus or minus can be determined by specifying a quadrant in some way. So for example, if I added to this problem, if theta is in quadrant, not quadrant 0, if theta is in quadrant 3, then I need to know if sine is positive or negative, and in quadrant 3, since sine is represented by the y-coordinate, y-coordinates are negative in quadrant 3. So I'd come back over here and select only the minus, the negative square root, to be my solution. Here's a harder example. Let's list our 3 Pythagorean identities and choose which one we will use. When we look at these 3 Pythagorean identities, none of them has tangent and cosecant. So something's going on here. We have to go a little bit further. You need to be able to imagine that instead of sine here, you could write that as 1 over cosecant squared, since sine and cosecant are reciprocals. So these two yellow guys are exactly the same. So anytime you see a trig function, you could actually think of its reciprocal being in its place. Okay? So think about that for a second. We'll use that logic to determine which one we can get tangent and cosecant in. Well, the first one, there's no way to get a tangent because the reciprocal of sine is cosecant and the reciprocal of cosine is secant, so neither one of those would give us a tangent. The second one has the tangent, but it has secant, or its reciprocal cosine. That is not the same thing as cosecant, so this one's out. The last one has cotangent, which is the reciprocal of tangent, so that's good. Cosecant, and we need cosecant, so that's good. So this will be the identity that we use. The first thing we should do is rewrite it so that we actually see tangent and cosecant. So if I do that, it'd be 1 plus cotangent is 1 over tangent, so cotangent squared is 1 over tangent squared, and cosecant I don't want to mess with because I need that in the equation anyway. Now we do the algebra to solve for tangent. So the first thing I would do is subtract 1 from both sides. And the second thing I would do is take the reciprocal of both sides, which gives me tangent squared of theta, and on the right side I have 1 over cosecant squared theta minus 1. Finally, take the square root of both sides. The square root of 1 is 1. The square root of the denominator is the square root of the denominator. And now we determine the plus or minus by the quadrant. Tangent is the opposite over the adjacent, or the y over the x. And in quadrant 1, y and x are both negative, so y divided by x is positive. So I need this entire side to be positive. 1 is positive. The square root is positive. Therefore, I need to choose the positive here out of the plus or minus to keep the whole thing positive.